Now it is good. Now is my voice okay?
Yes, sir.
Okay, nice.
Yes.
So we have an arithmetic progression with integers. Sum of the first two terms is -2, and second and third term, the product is 5. The least number of terms, no, the least number of the term which exceeds 2022, find the least number of the term that is greater than, strictly greater than 2022. So any ideas? Should we, so what have you people done in this?
Sir, I have not yet tried the question.
You did not? Sorry? You
Sir, I
didn't
have
try?
not yet tried the question. 1 second, I'll just try it.
Yes, yes. So please try this. Meanwhile, I'll find the other one. Other one is 24, I can see. So give it a try now again, Ishana maybe, and then just discuss. Ishana, you can tell us maybe what you have tried, because you would have tried this.
Sir, I didn't try this question. I skipped it actually.
Oh, you skipped it. Okay. Okay. Then let us try this a little bit. See, this is an arithmetic progression. Arithmetic progression, we know the definition, right? It would be like A1 and then A1 plus constant. It's just that it increases constant, right? By a constant D. That's all. There is nothing profound about an arithmetic progression. So try this now with this. It seems like we won't need much. So let me know when you get something. You can also try to use the fact that you already know that it's integers. Okay.
Sir, we have to first find A1, A2, and A3.
That may be the ideal, that may be the case, I don't know. But you can find it, I think. There is enough information. So it's like you see, it's A2 is A1 plus D, right? That is the arithmetic progression, right? A3 is A1 plus 2D, and so on. So if you simply put these values in these equations, you'll be able to solve for A1 and D. Okay? I'm not saying that's the
Sir,
best.
I got A1 as -3, A2 as 1, and A3 as 5.
That's it. So you have found it, right? -3 and A2 is 1. And so the common difference is 4. Common differences. Now the question is, when is the first time this becomes more than 2022? Aparna, you can see this is also this is the solution. This is the arithmetic progression that we have. Okay. Now try to figure out when is the first time it goes more than 2022. So see, after n steps, how will it look like? Right? The nth term will look like this. Am I right?
Sir, why is it n-1?
Why is it n minus 1? So you see the first term is -3. Second term is -3. You can see the second term is A1 plus D. Third term is A1 plus 2D.
Okay, sir.
Right. And even rigorously speaking, right, you are one step behind always, and the common difference is getting added from the second term. So that's maybe that is the thing that we need to, the new thing maybe you can say to know. But now you know the nth term looks like this. So when is the first time? What is the smallest n for which this is at least 2022?
Sir, I think 508.
What is the method?
Sir, the AN should be greater than 2022 or
Yeah, greater than. Right. You want to know when does something like this become more than 2022? Exceeds. Right? And then you find n. What should n be? I think you've already calculated it. And you're getting 5 and 4. Let us see. N should be greater than, how
Sir,
much is that?
58.
No, 58 is too less. 508, right? She's getting.
Yeah, 508.
N should be greater than 508. So 508 will not work.
Sir, I got n should be greater than 57.25.
Oh,
No,
sorry. Then
507.25.
sorry, and then I'm just making a mess. Okay. Oh, you're right. Yeah, this is 4, right? 507.2. Yes, right. And so 508 should work, right? Because all these steps are reversible. Right? You don't even have to like put in check whether it actually works. All these steps are reversible. There's nothing to worry about. So 508 is the answer. Okay. You can keep in your mind like there is no formula really here. It's just common sense. Yes. But nth term looks like this. Yep. What if I did not give this condition? Let's see, can we still do this problem? What if we only had the second condition? And increasing AP. Let's say I told you it's an increasing AP.
Sir, if only this case is there, then the first one is that, I mean, when I solved it only using this actually, then I got three cases. That is A equals to 1 and D is equal to 4, which we took. And another one is A is equal to minus 5 and D equals to 4. And another one is A is equal to minus 1 and D equals to minus 4. So basically, if you take the other two cases, then uh, we want the least number of the term which will exceed 2022, and if you take the other two cases I found, it will take more longer to exceed 2022 because it start A is a negative number, so it will take more time to exceed.
Okay, once again. Okay, that there's a but I just want to know first the key thing you have said is that there are three possibilities. Can you just say the three possibilities? A equal to what? And
Sir, A equals to 1 and D equals to 4. And then A equals to minus 5 and D equals to 4.
A equal to minus 5 and D equal to 4, right?
And A equals to minus 1 and D equals to minus 4.
Right. Okay. Now one second. So this is no. So let's first try to see how these cases are coming. Let us try to see. Okay. So see, one you can see that from here that A2 is equal to 1 and A3 is equal to 5 is one possibility because these are integers, right? So this is one possibility, and the other possibility is that both are equal to minus 5. So I'm not calculating A and D. Aparna has already calculated A and D also, but I'm just observing the number theoretic aspect only. Okay. So do you agree that these are the only two possibilities that I am getting? Is there any other possibility?
Sir, the case when A2 is minus 5 and A3 is minus 5.
Yes, right. And similarly, you are right. There are those possibilities. The reverse of these. And there is another one, but then as probably you can understand. So the good thing that we are in integers tells us that there are only these possibilities. Otherwise, we don't know, right? It's 1 by 5 and 1, right? 2 and 5 by 2. We don't know anything then. Because we are in integers, these are the possibilities. Out of these possibilities, I would immediately, we can chalk out, we can remove two of the possibilities. Which two can we remove? Immediately. Last one we can remove because this means it's a decreasing AP. It will never reach 2022. Yeah, in that
Second one also.
second one also. So I'm getting only two possibilities, and well, yeah, this third possibility also that Aparna has probably taken here, this will also not work because it's minus 4. Right? So these two, and then as Aparna has said, you can, so there are two possibilities and you can try out both the possibilities and you'll actually get two answers. Okay. you'll get. So actually, so in some sense, the answer is not unique because the APs are different. But if the question is, out of all possible APs that satisfy this, right, then you have to take the fastest AP, and that's the first one, right? So now there is a competition between APs because there are two APs, and as Aparna said, obviously you can see the first one will win because we want the least term. So there are several possibilities, but if we have to choose one, then it's okay. Take care. Yeah, so you can see that, I mean, this question can be even generalized further, like if it's like this, something like this. There are also several cases, but some of them you can immediately chalk out. But then you'll become smart, and then you'll immediately pick the fastest AP. You'll pick that factor which will give you the fastest AP, maybe, right? So that's up to you. Maybe 1, 2, 3 is the fastest one, right? Something like that, right? You can figure that out. So, yeah. So these are the kind of things.
So 1, 2, 3 is the only one here, right?
That is probably also correct. Yes, right, because the other things won't form anything. Yeah, right. Yeah, other things, kind of things are there, but they won't form an AP. Good one. And so these are the things, right, that you're combining the things, right? You're combining this so many aspects of the question, and you're reducing the cases. You don't have to really consider all of them, like you've already observed nicely. So these are the things, and then these are the calculations that already Varna has done. And so, yeah, there are other ways to shorten the thing, but let's move to the next question. Then we can go. So it's okay. It's okay. Now let us go to the next. The next one is a geometric progression. Yeah. Also, I wanted to say that this Sunday we have IOQM. So if you guys think it is useful, that is, you could decide, and it's not mandatory, then we can do a class on Tuesday. Okay. Tuesday also we can do a class early, 8 we can do. Okay. Also Tuesday some other thing was off, but in the point is that, yeah, if you think it will be useful, then you can join at Tuesday 8, and we can see, we solve these kind of questions in a more rapid way as we can. Okay. Tuesday 8 p.m. Okay. And then after that we'll have on Friday, and then also Ishana has cleared the first stage of NMTC, right? Yeah, so that's a good news. Let's see, IOQM is a more difficult exam, so we'll see. It's not a problem. Is this the first time for both of you writing the IOQM?
So for me,
Yes.
it's the first time.
Ishana,
But even for me, it's the first.
okay, first time. Okay, yeah, so it's okay, first time. And you give your best. See, yeah. I mean, I have not gone. I have not done it in things in a rapid way. That is a little bit of a problem from my side. I've taken my own sweet time and done things. Yeah, it has good sides and also bad sides, maybe from exam perspective. But we have covered more stuff than that's than before. But yeah, maybe we went a little slow, but that's okay. I hope we are doing things solidly. Like, it's not like you are getting uncomfortable with certain topics and you're leaving them. I hope that is not happening. Okay? So, okay. Do give me feedback as things evolve and let me know, because I've also been teaching for like maybe 2.5 years. Okay, maybe, yeah, this much whatever I teach, weekends mostly, 2.5 years. Yeah. Okay. So, let us see. Let's move to the next question, 24th. Yeah. The difference between fourth and first terms of a GP. So this is the geometric progression, right? So do we all know the definition of geometric progression? It starts with some term, and then instead of addition, constant addition, there is a constant multiplication. Like this. Okay, geometry progression. So difference between the fourth term and the first term. Two. The sum of the first three terms is half of this difference. Six. And the nth term of this GP just exceeds 2022. Again, same thing, right? Just exceeds means it's the smallest term which exceeds, right? So find, again, it's the same thing that you want to know. Find the smallest term bigger than equal to, no, bigger than. So try it and see. Just try it. I'll just come in a minute. Right. Let's do this one. So have you got anything? No? Yes. So like again, we can just assume that it's like A1, A1R, sorry, A1R square and so on. Oh, what is that? Like this. Maybe we just put the values, right? Is this what you people are doing or anything different? Now you need to find A and R. So please let me know what you are getting. So like we have two equations and we have two variables A1 and R and we want to solve them.
So it is R3.
Okay. Let's see and then A. I've not calculated. I don't know. Then A will be 2, right? Let's see if Aparna is getting that. Uh, Maybe Ishana, you can tell how you have found
Or
R.
even I got it.
Right. So you can tell how you have found R.
Sir, I divided both the equations, so A1 got cancelled. So
Yeah.
R cube minus 1 by 1 plus R square. That is R minus 1 is equal to 2.
R minus 1 is equal to 2. So you have cancelled this thing.
Yes, because the factorization.
Right. But you see, that is not incorrect. But let's see. Aparna, have you done the same thing or anything different?
Or even I did the same.
So if when we cancel this, why can't we just cancel this and not account for any R from there? Wait, okay, what if you had something like, like something like this, could you then also cancel, like, could you then also cancel the thing? No, right? Because when you're canceling this, what does it mean? Yeah, it really means that you are saying, okay, it's like this. And so you're saying are either this is 0 or this is 0, right? When this is 0, then r is equal to 3. When this is 0, r is equal to 2 or 3. Right? When we cancel something, we have to also see for what values it could create equality. Right? Or for what values is it 0? Because that's how you will get both sides equal to 0, which is also fine. So r equal to 3 would also work in that case. And r equal to 2 also, that's the extra thing. Okay.
So we have to assume r minus 1 is 0.
No, assume r minus 1 is 0. Why? No.
Like you had said that either of the two terms we have to assume to be 0 to find the other.
No, I don't mean assume to be 0. No, I did say that, yeah. I mean, what I mean is that when you, okay, see, first thing is that mathematically you can see that, okay, forget the cancellation. And there are many ways one can say this, but this, mathematically speaking, it is this. Or, I mean, not that one. I mean, this one is mathematically speaking this, right? And this gives you possibilities 2, 3, and 3. So basically 2 and 3. Right? And 2 and 3 both satisfy the equations. Right? So if you would have just cancelled this, then you would have lost the solution if you don't, say for what values it is 0. Right? So think about this. We'll just clear this up more on the after the meeting. Just end the meeting and launch it again.